Hello, good morning, students. In the last lecture, we had studied closed chain structure of glucose. Today, we will study closed chain or the ring structure of fructose. We know glucose and fructose are functional isomers. They are having same molecular formula, that is C6H12O6, and they have different functional group. In glucose, aldehyde functional group, and in fructose, ketone functional group. This fructose is leo-rotatory, that is, it show rotation towards left side, that is, it is optically active. It shows negative rotation. It is a ketohexose because containing ketone functional group and 6 carbon atom containing sugar. Fructose is also called as a levolose because of this Leo rotation. This rotation is alpha D20. It is minus 92.4 degree. So being this alpha hydroxy keto compound, fructose is a reducing sugar. Due to this ketonic group, it is a reducing sugar. In the free state, it exists as a mixture of fructopyranodes as a major part and fructofuranodes as a minor part. In combined state, fructose is found in the form of fructofuranodes ring, and this ring structure of fructofuranodes that we will study how to draw this structure. The name given as a fructofuranodes because of the analogy, that is furan. The structure is similar to furan, hence the name given as fructofuranodes. It is a 5-membered heterocyclic ring compound, cyclic compound, and we will study how this alpha anomer and beta anomer of fructose can be drawn easily. The structure of fructose is hemiketal. We had studied the glucose is hemiacetal. Now it is hemiketal. Now how to draw this closed chain structure of fructose from this feature projection formula. We know molecular formula of fructose is C6H12O6. Its Fisher projection formula can be drawn like this. This is carbon number 1, CH2OH. Carbon number 2 have ketonic functional group. Carbon number 3 having H and OH groups. Carbon number 4 is again H and OH. Carbon number 5 H and OH group, and carbon number 6 is CH2OH. So this is formula of fructose. This structure is called as a Fisher projection formula for the fructose. Now we will study this fructose, how to draw this ring structure. Now here the fifth carbon OH, similar to glucose, this fifth carbon OH that forms the bond with second carbon ketonic group. Here this fifth carbon OH, that is a hydroxy group, alcoholic group, that forms the bond with carbonyl carbon of the second carbon, so that this carbon number 1 containing CH2OH group, that is maybe towards left side or maybe towards right side. So depending upon this OH group position is on second carbon. In one structure is to the right side and in other structure is to the left side. So depending upon this, it is called as a alpha anomer and beta anomer. These anomers differ from each other only by the position of OH group at second carbon in one structure is to the right side and in other structure is to the left side. So that is the only difference, and these structures are called as anomers. See this carbon number 1 CH2OH, that remains as it is. Then carbon number 2, that C double bond O becomes the COH. Carbon number 3 have the similar groups OH and H. Carbon number 4 have H and OH, the same groups in both anomers. Carbon number 5 have H one side and other side oxygen get bonded with second carbon in both structures, and carbon number 6 is CH2OH. Now this ring structure is called as a Haworth projection formula for fructose, and this structure is similar to a heterocyclic compound furan, and therefore the name given for the cyclic structure of fructose as fructofuranones. Here the carbon number 1 containing CH2OH, carbon number 2 is bonded with OH group, carbon number 3 have OH and H, carbon number 4 HOH, carbon number 5 one side hydrogen and other side, that is the CH2OH, that is the sixth carbon. So here in this structure alpha anomer, OH group on second carbon is below the ring and it is called as a alpha side, and hence it is called as a alpha D minus fructofuranones. In other structure, this is carbon number 1. Carbon number 1 is CH2OH. Then carbon number 2 have OH. In first structure, it is below the ring. In this structure, it is above the ring. It is towards the beta side, that is above the ring. Then remaining groups are same as in the alpha anomer, and this is called as a beta D negative fructofuranones. So this is a closed chain structure of fructose called as a Haworth projection formula, and it is drawn from this structure called as a Fisher projection formula. And that is about the closed chain structure of fructose. Thank you.